Hello, and I welcome you all to Scientific Study for You. I am Apur Pathak, and after watching this video, Aufbau principle, an underrated yet very important topic, will be crystal clear to you. And you will be able to write the electronic configuration of elements in SPDF format. And you will also be able to solve the questions frequently asked in competitive examinations about arranging the orbitals in order of increasing and decreasing energy. So let's get started. So the electrons are filled up in the empty orbitals of an atom from the lower energy orbital to the higher energy orbital. It means that the electrons will enter the higher energy orbital only if the lower energy orbital will be fully occupied with the electrons. Okay? It means that 2s electrons will get electrons only if the 1s orbital will be completely filled. So let's see the diagram, this diagram here. This diagram will be helpful in writing the electronic configuration of elements. We can make the format how to write the electronic configuration with the help of this diagram. So we have to write the orbitals in such a way like 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, and having gap between each of them. Okay, write all this. And after that, the downward arrow, this slant downward arrow will give the direction in which we will write the electronic configuration. For example, it will be 1s, then 2s, then it will be 2p, then 3s, then it will be 3p, 4s, then it will be 3d, 4p, 5s, then it will be 4d, 5p, 6s, and so on. Okay, so I have written here, as you can see, it will be 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and so on. Okay, don't worry, I will show you the examples. Okay, so I have written the electronic configuration of first 20 elements. Try to see this. Okay, so here hydrogen, it's having one electron, so it will go in the lowest energy level, 1s orbital. Okay, so it will be 1s1. Then it will be, for helium it will be 1s2, then for lithium it will be 1s2, 2s1, and then for beryllium it will be 1s2, 2s2. And see carefully here that 1s2, 2s1 can be written as helium 2s1. Okay, because 1s2 is the electronic configuration of helium, which is a noble gas. Okay, so in this way, boron 1s2, 2s2, 2p1, carbon 1s2, 2s2, 2p2, nitrogen 1s2, 2s2, 2p3, and so on. As you can see, oxygen 1s2, 2s2, 2p4, and you can see aluminium 1s2, 2s2, 2p6, 3s2, and 3p1. It can be written as neon 3s2, 3p1, and neon is the noble gas with electronic configuration 1s2, 2s2, 2p6. Okay, so it can be written like this way. Okay, so the format we write for writing the electronic configuration is, again I am writing here. Okay, so it's 1s2, 2s2, okay, 2p6. It will, and here the maximum number of electrons on it. All right, 2p6, then 3s2, okay, then 3p6, then 4s2, okay, then 3d10, okay, then 4p6, okay, then 5s2, okay, then 4d10, okay, then 5p6, then 6s2, okay, then 4f14. F orbitals are having the capacity of 14 electrons, as you know already. I have discussed in the quantum number videos. Okay, and then 5d10, then 6p6, and 7s2. Okay, so this way and so on. Okay, this is the format. So we will try writing the electronic configuration of European. Okay, 63 atomic number. Let's see, it will be 1s2. Okay, you can see here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 20 electrons up to here, 2 to 4, 6, 10, and 8 to 10, yeah, 40 electrons up to here. Then 3d10, 30 electrons. Okay, 4p6, okay, then 5s2 and 4d10. Okay, how much electrons? 30 here, 36, 38, 48. Okay, 4d10, then 5p6, okay, 48, 6, 54. Okay, 54. After that 5p6, then 6s2, it will be 56. So 7 more electrons. It next will be 4f, Okay, so we will put 7 electrons in the 4f, then it will be 4f7. Okay, that is the electronic configuration of atomic number 63. So it's easy, you can try doing this. Okay, but always keep in mind the exceptions. Okay, there are a few exceptions in this. Okay, let me tell you the exceptions which doesn't follow the above principle. It's chromium, copper, Nb, Mo, Ru, Rh, Pd, Ag, La, Ce, Gd, Pt and Au. Okay, so actually I have made a full detailed video on electronic configuration, okay, in the KLMN format. That's a very useful video. Okay, if you have watched that video, then this electronic configuration will be a piece of cake for you. Okay, it will be very easy. So nothing big in this. Okay, so let's move on to the next topic. It is energy comparison between two orbitals. This question is frequently asked in competitive examination, a very common type of question. Okay, you will see this question many times. So energy comparison between two orbitals is done with the help of a n plus L rule. As you can see, n plus L rule. It states that first of all, smaller the value of n plus L for a particular subshell, smaller will be its energy. Okay, it means that suppose for example here 4s and 3d. Okay, in case of 4s, the value of n plus L will be 4, okay, which is the principal quantum number, and L which is the azimuthal quantum number. Okay, so its value is 0 here, and the sum is 4. Okay, in case of 3d, n plus L will be 3 plus 2, which is 5. So as you can see, the value of n plus L is lower in case of 4s and is higher in case of 3d. That's why the energy of 4s will be lower than of 3d. Okay, as you can see here. Okay, now the second rule, that was the first rule of n plus L rule. Okay, now the second rule is, if for the two subshell the n plus L value is the same, then the subshell having higher value of n will have higher energy. Now suppose if you have 3d and 4p, for 3d you can see that 3d will be principal quantum number n equal to 3, and d for d azimuthal quantum number will be 2. So n plus L will be 5, and for the case of 4p, n plus L will be 4 for the principal quantum number, and for p it will be 1 azimuthal quantum number. So 4 plus 1 5. Now both the 3d and 4p having the same value of n plus L 5. Now in this case, how you will decide which will be in lower energy or which will be in higher energy? So for this case, this is the rule that the orbital with higher number of principal quantum number will be having higher energy. Okay, for example, in this case 3d and 4p, 3d is having n plus L equal to 5 and 4p is having n plus L equal to 5, both are same. So in this case, the one with higher principal quantum number is higher in energy. Alright, so this was the n plus L rule. It was very easy. Now let's compare few energies of the orbitals with the help of n plus L rule. Okay, it's 5p orbital here. Okay, so in case of 5p, n plus L will be 5 plus 1 equal to 6. In case of 4s, 4 plus 0 equal to 4, 4d, 4 plus 2 equal to 6, 3d, 3 plus 2 equal to 5, 4f, 4 plus 3 equal to 7, 6s, 6 plus 0 equal to 6. Okay, I hope that you all know about the quantum numbers, the 4 quantum numbers. Okay, and if you don't know properly, you can check out my videos. I will give the links in the description. Okay, so as you can see, these are the values of n plus L for these orbitals, and the lowest is this 4, and it's the 4s. That's why the lowest in energy will be the 4s orbital. Okay, the next is 5th, and 5th is 3d. So the next will be 3d in energy. Okay, now the next 6. There are three n plus L values 6. 3 such orbitals having n plus L equal to 6. Okay, it's 5p, 4d and 6s. Now in this case, we will compare which is having the lowest number of principal quantum number. As we can see, 4d is having the lowest value of principal quantum number. That's why the next will be 4d. After that, the next lowest value of quantum number is 5p. That's why the next will be 5p. And for the n plus L value 6s is having the maximum number of principal quantum number. That's why 6s will be highest in energy in among 4d, 5p and 6s. Okay, and 4f is having 7 n plus L value. It will be the highest in energy. So this will be the energy arrangement. Okay, Very easy, there's nothing complex here. Now we will solve few questions which has been asked frequently in JE and NEET examinations. Okay, so let's start this. So first question is, correct set of 4 quantum numbers. Okay, correct set of 4 quantum numbers for the valence electron of rubidium is, whose atomic number is 37. Okay, so for rubidium, the correct set of 4 quantum numbers for the valence electron, in such case we will have to first of all we will have to write the electronic configuration of rubidium. So it's Z is equal to 37, so we will write as 1s2, 2s2, okay, 2p6, 3s2, 3p6, 4s2, okay, 3d10, okay, then 4p6, okay, 4p6 and 5s1. This is the electronic configuration. So as you can see, there is one electron in the valence shell, which is the fifth shell, okay, and this is one electron. So for this electron, principal quantum number value n is 5, okay, value of azimuthal quantum number L is 0 because it's the s orbital, okay, for s orbital or for s subshell, the value of azimuthal quantum number is 0, and for L is equal to 0, value of m will be 0, okay, and spin can be plus minus 1 by 2. So we will check the option which is having 500 plus minus 1 by 2. Okay, so as you can see, the first option 500 plus 1 by 2, it is same as our this solution. That's why this will be the answer. Okay, next question. And by the way, this question was asked in IIT 1984 and also in JEE Main 2014. Okay, you must be knowing that these are the important examinations you all appear for. Okay, so let's move to the next question. Okay, next question is, the orbital diagram in which the Aufbau principle is violated is. This again has been asked in an IIT 1988. Okay, so in the following 4 figures, in which of the following the Aufbau principle is violated? And if you try to remember, the first sentence I have said while explaining the Aufbau principle in this video was that the electrons will be filled in order of increasing energy, which means that first the lower energy orbital will be filled, after that the higher energy orbital will be filled. So it means that if this is one orbital, okay, then this orbital will be filled, then only these orbitals will be filled, because this is clearly s orbital, okay, and these are the 3p orbitals. Okay, so first s orbital will be filled in this case, then p orbitals will be filled. Okay, so this option is correct according to that. First s orbitals are having 2 electrons, then only p orbitals are getting filled. Okay, in C and D options also you can see here the first s orbitals are filled completely, then only the other orbitals are getting filled. The only option B in this, without the s orbital getting completely filled, the p orbitals get started filling up. Okay, that's why this is the option which is not following or violating the Aufbau principle. Okay, so this will be the answer. Okay, very easy, nothing complex in this question. Okay, let's move to the next question. Next question is, the correct set of quantum numbers for the unpaired electron of chlorine atom is, and this question has been asked in 1989 IIT. Okay, so for chlorine, what is the electronic configuration? You can tell me. It will be 1s2, 2s2, 2p6, okay, 10, 3s2, 12, and 3p5. This will be the electronic configuration. So it's saying the unpaired electron of chlorine. So let's draw the 3p orbital having 5 electrons in case of chlorine atom. Okay, so 1, 2, 3, 4, and 5. So this is the 3p electron which is unpaired. Okay, in this case the principal quantum number n is 3. Okay, in this case azimuthal quantum number L is 1 because it's a p orbital. Okay, for L is equal to 1, value of m will be minus L to L, that is minus 1, 0, and plus 1. Okay, and spin can be plus minus 1 by 2. Okay, so let's see the options. It's asking only 3 quantum numbers, n, L, and m. So our n is 3, so C and D both can be correct. You can see our L is 1, so clearly option C is correct, and m can take any value from minus 1, 0, and plus 1. Okay, That's why option C is correct. Alright. This was also very easy, a piece of cake, as I said. All the questions of above principles are very easy. You can score 100% from this topic. That's why I said underrated yet very important topic. Right. Okay. So the next question again. The next question. Okay. The question 4. In this question, the electrons identified by quantum numbers n and l are these 4 electrons, 1, 2, 3 and 4. Okay. So these electrons can be placed in order of increasing energy from the lowest to highest as, okay, so we have to compare the energy. So let's write the sum of n plus l first so that we can compare easily. Okay, for this one, n plus l is 4 plus 1 which is 5, for 2 4 plus 0 which is 4, for 3 3 plus 2 which is 5, and for 4 3 plus 1 which is 4. So these are the n plus l values for these 4. We can clearly see 2 and 4 are having the same values and 1 and 3 are having the same values. Okay, so for energy we can compare like this. First of all, n plus l lower value 4 will be the lowest in energy. So here n equal to 3, here n equal to 4. The second rule says the one with lower principal quantum number will be in lower energy if the value of n plus l is same. So the lowest will be here 4, right? Because principal quantum number is 3 here and n plus l is 4 here. The next will be 2. Okay. Oh, sorry, it will be like this. 4 is the lowest. Okay, then 2. The next will be in 5. In case of n plus l equal to 5, here principal quantum number is 3, here principal quantum number is 4. That's why this will be first. So third will be first, and the highest energy will be this. Okay, 1. So this will be the answer. Let's check from the options. 4, 2, 3 and 1, right? 4, 2, 3 and 1. So option 1 is correct. As you can see here, option 1, 4, 2, 3 and 1 is the correct answer. Many times it happens like they ask decreasing also. So be careful in the question while attempting. Okay, it should not be like that. They asked decreasing order and you ticked or you marked the increasing order. Then you will get -1 for sure. Okay, so let's move to the next question. Next question is, which of the following sets of quantum numbers is correct for an electron in 4f orbital? Okay, here 4f. So this question was asked in AIEEE 2004. Okay, 4f. All right. So here principal quantum number n is 4. For f, azimuthal quantum number is 0, 1, 2 and 3. Right. So 0 for s subshell, 1 for p subshell, 2 for d subshell, and f for 3 for f subshell. Okay. So L should be 3 here, and for L3 value of m will be -3 to +3. While taking all the values between them, that is -2, -1, okay, -2, -1, 0, +1 and +2. While taking all the values, -3 to +3. Okay, and spin will be ±1/2. Okay, 1/2. So let's check the options where n is 4. Okay, in 3 options n is 4. Let's see L should be 3. In 2 options L is 3, A and C. Okay, and M should be -3 to +3. In option C you can see M is +4, which is not possible. That's why A will be the answer, because in A it's +1. Okay, so A will be answer. Very easy, no problem at all. So let's move to the next question again. In the next question, it is question 6. Okay, it's question 6. In this, in a multiple electron atom, which of the following orbitals described by the 3 quantum numbers will have the same energy in the absence of electric and magnetic fields? This question been asked in AIEEE 2005. Okay, so they are asking which of them will be having the same energy. Okay, and without like in the absence of electric and magnetic fields says that you don't need to consider the magnetic quantum number. Okay, it means that there is no meaning of this M. We have to just see n and l, and we will have to find the n plus l. Okay, so in case of A, n plus l is 1. In case of B, n plus l is 2 plus 0, that is. In case of C, it is 2 plus 1, which is 3. In case of D, it is 3 plus 2, which is 5. And in case of E, it is 3 plus 2, which is 5. So in case of D and D, both are having the same value of n plus l. Okay, and in this case the value of principal quantum number is also same. It means that it's representing the same subshell, just two different orbitals of the same subshells, which are known as degenerate orbitals. Okay, that's why these both orbitals will be having the same energy. So the option should be D and E. Okay, let's see. D and D, option A is the answer. All right. So easy question. Look, it's giving you, if you are attempting JEE main, it will give you 4 marks for free. Nothing big in this question. It's giving you 4 marks. And suppose if you if you wrongly answered it, you will get -1. So it will be a big loss. That's why this topic is very necessary. Okay, it's the, like, you know, many we say that in the field of chemistry that this is energy giving substance. So this is marks giving question. Okay, so let's move to the next question. Question 7. Okay, so which of the following sets of quantum numbers represents the highest energy of an atom? Okay, highest energy of an atom, AIEEE 2007. So highest energy should be the atom with highest value of n plus l, right? And if two if two electrons will be having the same value of two orbitals, electrons will be having the same value of n plus l, then the one with maximum principal quantum number 1 will be the highest. Okay, so let's see. First is 3 0, so n plus l is in this case 3. Second is 3 1, so in this case it will be 4. Okay, third is 3 plus 2, which is 5. Fourth is 4 plus 0, which is 4. So clearly C option is the one which is having highest value of n plus l, 5. That's why it will be the one with the highest energy. Okay, very easy again question. Let's move to the next question. Okay, this time the electrons identified by quantum numbers n and l. Okay, these are the 4 electrons identified by n and l, and the question says can be placed, okay, can be placed in order of increasing energy. Okay, so for that we will have to check the question, and again we will have to write the value of n plus l. Okay, so for this case n plus l will be 4 plus 1, which is 5. In this case n plus l will be 4 plus 0, which is 4. In this case n plus l will be 3 plus 2, which is 5. In this case n plus l will be 3 plus 1, which is 4. So here, okay, 2 are having the same value of n plus l, and other 2 are having also same value of n plus l. So for determining the order, first of all, the value of n plus l equal to 4 will be the lowest in energy, but we will have to check the value of principal quantum number as well. Okay, so in this case the principal quantum number is 3, in case it is 4, that's why D will be lowest in energy. Okay, after that it will be B. Okay, then we will check in case of 5 that which is having the lowest value principal quantum number. C is having 3 principal quantum number and A is having 4. That's why then it will be C, then it will be A. Okay, so it should be D, B, C, A. So let's see options. D, B, C, A. So here you can see option B is the correct answer. D, B, C, A. Okay, let's move to the next question again. And by the way, that question was asked in JEE Main 2012. Okay, and this question is asked in AIPMT 2011 for the NEET students. Okay, this was a medical question. So if n is equal to 6, the correct sequence for filling of electrons will be, okay, the correct sequence for filling the electrons will be. So if you remember, I had written the electronic configuration. Okay, let me show you once again here. As you can see here, when n was 6, okay, after that the electronic configuration format was 6s, 4f, 5d and 6p. Okay, which means if n equal to 6 here, if n is equal to 6 here, so it was, okay, n, okay, ns, then it was n minus 2f, then it was n minus 1d, then it was np. So it was ns, then n minus 2f, then n minus 1d, then it was np, right? Let's check the options if we are having. Okay, let's check the options. ns, n minus 2f, n minus 1d, and np. Clearly you can see option D is correct, all other are wrong. That's why D is the answer. AIPMT 2011 question. Just you needed to remember or know the strategy to write the electronic configuration as PDF format. If you remember that, you could have answered this question very easily. You can see, right? Okay, next question again. Next question. It is from NEET 2016. Okay, the electronic configurations of EU, okay, EU, Europium, GD, and TB, okay, atomic number 63, 64, and 65 are, okay, now pay attention here. Let me show you. This is a tricky question. In here, GD is an exception. If you remember, let me show you. GD was an exception. Here, as you can see, GD is the exception. Okay, so in this case, I will write the electronic configurations. In case of EU, it was, for EU it was 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2, 3d10, 4p6, 5s2, okay, 5s2, 4d10, 4d10, okay, then 5p6, 6s2, and 4f7, right? Here 20, 30, 38, 48, 54, 56, 7, 63. It was EU. Okay, so look at the options. Up to this it was xenon 5p6. Okay, it was xenon. After that 6s2, 4f7, 6s2, 4f7, 6s2, 4f7. Okay, so the answer will be from C or D. We will have to check the next one, which was the trickiest one, GD, right? For GD it will be xenon. Okay, xenon means up to here. Okay, xenon means up to here, xenon. Okay, 6s2, 4f6, and 5d1. This is the electronic configuration. As I said, it was the exception. In this case, one electron gets shifted to the 5d subshell and takes the 5d orbital. Okay, that's why it's having an electronic configuration 4f6 and 5d1. And in case of TB, okay, it was 64 and 65. Again, it's xenon. Okay, xenon. After that 6s2, and it's not the exception. That's why it will be having 6s2. Okay, it 6s2. Oh, sorry, it is 4f7 here because one electron more than EU, right? It was 63, it was 64. Okay, that's why it will be 4f7 and 4f7 and 5d1 from the option. There is only one option which is having 4f7 and 5d1 6s2. Okay, which is this option D here. Okay, but let's write for TB as well. Okay, in case of TB, 6s2, 4f9 will be the electronic configuration because it is not the exception, right? Similarly to EU, whose electronic configuration was 6s2 and 4f7, it is having 6s2 and 4f9. Just GD was the exception. That's why this question was asked in NEET 2016, and D is the correct answer. All right. So I would like to conclude the video that we have learned the above principle, which states that the electrons should be filled in order of increasing energy, and the orbital which is lower in energy will get filled first before the orbital in higher energy. Okay, and we studied the n plus L rule, which states that the first rule was the orbital will be higher in energy whose value of n plus L will be high. Okay, and if the value of n plus L for two orbitals will be same, then the next rule was the one with higher value of principal quantum number will be higher in energy. Okay, so and we have solved very easy questions asked in JEE and NEET, as you can see, and you can now write the electronic configuration as well. We have discussed that part as well. Okay, so that was it in the video. Thanks for watching.